Welcome back, everybody. Today we are continuing on with our law of cosines. Just as a recollection, last class we proved the law of cosines rather than derived. Sorry again about the issue that we had deriving it. And then we worked one example together. Here was another example that we came close to finishing, and I asked you guys to finish at home. If you didn't yet, we will survive. You should finish it. Okay, it is in your interest to finish it. But we are going to run immediately back to swim back to everybody's favorite type of problem. We're going to do an application problem. So I will pause it. We are going to play around with some boats here for just a minute. Boats and bearings, love it. Little B&B. All right, I'll give you a second. Jot this down and we'll attack it together. Jot it down and draw your picture. Have this, and then I'm going to turn, and then here's the question before we commit to drawing it. Am I going to turn toward the south or toward the north? Because I don't specify, we just turn. Toward the north? Sure. So check it out. Here we are, and I'll go ahead and say, look at this. Here's our wonderful dock. There it is. And we could probably label it, I don't know, D sounds reasonable. Here's point D for dock. Cool. Now I go west some distance. And I don't know exactly how long I travel, but how far did I go? So 25 miles. Here it is, 25 miles. Okay, and then I turn. And I don't specify whether it's north or south. Riley made the executive decision, we're just going north, and I'm fine with that. Now, what I don't know is on leg 2, I don't know if it's here or here or here or here. It could be any of these, right? So I'm going to hold off on drawing that one for just a second. I do know that afterward, I'm how far from the dock? So if we draw kind of to scale, and this is the distance from the dock, here I am, would you believe that that's a little bit more than twice as long? Okay, so I'm going to say, check it out. Here is my 62 miles, which means this last little piece right here, the second leg of our trip, must have been how long? 45. Scale-wise, does it look believable? Now, it doesn't have to be perfect, but it seems okay. All right. Now, just to show you guys, do not draw this one, but I want to talk about it. Is it possible that the 62 miles was actually down here? And then this would have been my other 45. And notice we get a completely congruent triangle, so all the angles and everything match, but the bearings will be different. If it says what bearing was followed after turn, this one right here would be the down answer, and it looks like we would start at south and go east. This one instead starts at north and goes west. Okay, but let's deal with this one. First off, what information am I given to tell me law of sines or cosines? Obviously it's cosines, but how would you know that if the example didn't say it? Side, side, side. Right off the bat, that's what I notice immediately. This is side, 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 which implies to me the law of cosines. Okay. Which angle am I looking for? I named this point D to be able to talk about stuff nicely. What do you want to call this point? There's not a right or wrong answer as long as you don't pick 0. E. Cool. Here's E, F. I'm cool with that. We have a triangle, 3 points. Fantastic. If I want to know the bearing that we followed after we turned, which angle am I trying to find? E. Remember, the bearings always start north or south. This is really the angle that I'm trying to find. Now, I can get that by just subtracting 90 from whatever angle E is. So let's find angle E on this problem. So here we go. We are just plugging and chugging. If I'm looking for an angle, should I have cosine of E equals some big long ugly expression, or should I have E squared equals some big long ugly expression? Which version of cosines should I use if I'm solving for an angle? The first one. So check it out. Let's dive in. I know that I'm trying to find E. So right off the bat, we have the cosine of angle E. And then I just kick right to that same way that I memorized the first time we talked about it. What are the two sides that aren't E? F and D, right? So check it out. Let's just take side F and do what to it? I'm going to make a fraction first of all, I'm sorry. Square it. So here's side F squared plus d squared, and I subtract, not quite. If you need to check, I'm cool with it. I think I probably have it right here. Hey, let's subtract the angle that we're working from, minus e squared. And now, Riley, I like that same comment you had. 2 and anybody can help. FD, good. FD. Now, I know all these numbers. Every single one of them. So, let's just see what we get. F squared is what? Not the number itself, but what's the number I'm squaring? 25 squared plus 45 squared minus 62 squared. Okay, so I know that that's going to be in a fraction. 62 squared. Let me fix that. Okay. I don't care where you're typing it in, whether you take the time to do this and then do the denominator. I'm going to divide by 2 times what times what? 2 times 25 times 45. Okay, this gives me the cosine of angle E. Now, we're all at different places calculator-wise. The next step, if I want to solve for angle E, to get it out of my cosine, what must I do? I'm going to take the arc cosine. So I'm not, it feels silly to write it, but I will. I'm going to take the arc cosine of both sides of my equation. And I'm going to cheat because I can. And I am ready for some answers whenever people get them and shout them out. 122.05. I have a second. I want everybody to verify that when you type it into your calculator, you can get that the measure of angle E is approximately 122.05 degrees. Just the whole angle. That's all we're doing first. Did you do it in 2 steps or did you do it in one big step? Cool. If you get something different, I would say check radians or degrees. We should be in degrees here. And then if you still get something different, let me know. We will find out where your mistake is happening. Divided by 2, you got the answer, and then multiplied by 25 times 45. You need parentheses around that. Don't think that if you just copy that line. I got you, Ken. I'm going to move your cookie. Check the mode, okay? Degree. Okay. Abigail, I'll guarantee when you change it, that'll happen. That'll fix it. Okay. Anybody like to see me type it in my calculator? Okay, so are you getting the wrong thing? So we're going to check something then. I'm going to back up one step. What is the numerator, Huggins? 25 squared plus 45 squared minus 62 squared.
Negative 1194.
I got to think if does that make sense? Yeah. 1194. Over, what's the denominator? 50 times 45, 5 times 45, 22, 5.
2250, yeah.
Okay, so now do me a favor. If you do this little scratch work, now in your calculator, try the arc cosine of negative 1194 over 2250. And I would American dollars on this. Cool. Okay. If you ever get domain error, which is happening because your argument is too big, take that extra step, calculate them separately, and then take the arc cosine. Okay, Is this my real bearing though? No, this whole angle right here we just saw was 122.05. What do I need to subtract from that to get only my bearing part? So when we subtract 90 degrees to get my bearing here, we wind up starting at north, and it looks like we turn 32.05 degrees. Which direction? So we start at north. Here we are, north, and we turn 32 degrees west. Love it. And look at that. We have our final wonderful bearing of our magic boat that doesn't have to actually go through water as it turns. It just stops and goes. Does adding the context make this any more challenging? Like realistically, I debated whether I was going to make you guys actually see the problem because as long as you have three sides of a triangle, you're golden. Cool. Doable. All right, we are going to have a bit of work time today. We have one more little thing that I would like to see before we finish the chapter. Section, sorry. Cool. Okay. Everybody, let me rephrase this. What questions do you have about any part of this process? Not with cosines. Never with cosines. Angle side side, if you want to talk about the ambiguous case, I'm happy to. But I assume it showed up on your homework. We can look at it. Yep, for sure. Okay, so we have one more cosine idea that I want to address here. And one person here has already seen it. One of the applications of the law of sines is we can find the area of oblique triangles all of a sudden. Because we have the height, we can make the height anyway by adding an altitude somewhere. And we can use cosine, sines, trig stuff to get the height and the base. Okay, we did that the other day. Turns out law of cosines is also going to give us a way to calculate area. So we're just going to say area from law of cosines. Because we did this with sines the other day, we're just going to finish it up. Okay, now it turns out this has another name. We're going to say the following. First off, this is known as, any idea what I'm going to say here, Riley? I feel like I've called on you like 4 times directly, but do you remember what you used the other day? Oh my gosh, you still remember it. Heron's formula. Okay, I believe Greek mathematician from a long time ago, which just the philosophy of mathematics, it always blows my mind that they were using trig stuff without calculators or without fancy calculus to approximate the values. Insane. I'm going to do some digging because I have no idea how this happened. Okay, now when we did area with law of cosines, or sorry, law of sines, we needed an angle given. We had to have one angle to get our area from law of sines. However, there are situations like side, side, side where we never happen to have an angle. So here we go. Given triangle ABC with A, B, and C provided, which tells me we're in which case? Side, 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 which screams law of cosines. Turns out it also screams easy way to do this problem. The area. Ooh, and I'm not going to call it A because we called it triangle ABC. The area is, and we're going to get a nice formula, which we can prove if you want to, but I'm not going to make us. Here we go. I have to write the word area instead of a capital A because of poor choice by me. Okay, super easy to calculate the area of this thing. It's a square root first and foremost. And then we have to do just a simple multiplication that's pretty easy to work out. We're going to do S, not a 5, this is an S, times S minus A times S minus B times S minus C. There's a natural question that should be at the front of everybody's mouth. What's S? Check it out. Super easy to deal with. It turns out it's just the average, almost the average. I lied. I'm not going to say any more about it. Where S is exactly equal to, you take the perimeter, which, how would you find the perimeter of this triangle? Say it again. Add all the sides. So that'd be a plus b plus c, right? A plus b plus c divided by 2. I'll make sure that's really clear too. Okay. This is as plug and chug as math gets. I'm interested in the proof. I've never seen the proof of this. I don't think I've ever, maybe I have, I don't recall it. I'm going to play around with this while you guys are working on stuff, and then if it's interesting enough, we'll talk about it. Cool. All right, let's do one quick example of this, and then the rest of the time is going to be yours to work. So let's see, I give you, given a triangle with sides, and don't write down the sides yet. I want you to tell me what's wrong with this, okay? I want sides 7, 9, and 20. Don't write them down yet. If I gave you this problem, I don't think you're going to find an answer. Anybody know why? I heard too long, too short. Maybe. I mean, I think I agree with you, but can you expand on that, Sean? Yeah, check it out. If we had a piece of wood that was 20 long, and another one that was 7, and another one that was 9, are you ever going to get these 3 pieces to form an actual triangle? No, this is called the triangle inequality, and for as simple of an idea as it is, it shows up in some really high-level math, like regularly. I need to make sure that any 2 sides sum up to greater than the third. That's what the triangle inequality tells us, so that we can actually build it. So, any suggestions here? 7, 9, and 13 is what I was thinking too, coincidentally. No idea why. Okay. I have a triangle of side lengths 7, 9, and 13. Cool. Right off the bat, I would suggest we calculate S out of this deal. Let's just find that first. So let's see. Can I change one of these to be, can I change this 9 to an 8?
Sure.
There's a reason. 8. Okay, the reason is going to become clear, I imagine, in a second. 7 plus 13 plus 8. 7, 13 plus 8 over 2. That becomes 28 over 2, which is 14. If I'd kept it the original, it would have been 29, and we would have had to deal with decimals, and I'd rather not. Okay, if you had to calculate S, half the perimeter, everybody cool with it? Awesome. So now let's just knock it out. The area is super easy. Because there's no ABC here, I can actually just do it. We're going to work out a few little pieces on the side first. What's S minus A going to be? 14 minus 7 equals 7. Love it. How about S minus B? We'll call it 14 minus 8 equals 6. And S minus C? 14 minus 13 equals 1. I have my 3 numbers. We are ready to just plug and chug. The area is the square root of, what do I have to put first before I do 7, 6, and 1? S, which was 14, times S minus A is 7, S minus B is 6, and S minus C is 1. Baller. Now, I'm trying to get an exact answer in my head. I don't have the answer here because there's some nice stuff that happens with the square roots that we could deal with really conveniently. We'll just go right to the approximation. Pure calculator problem. 24.248. Can I get somebody to second that? Awesome. Now, because we're talking about area, I am going to call it units squared because I didn't specify. Did you get a different number? Okay. Because I view this and I think about it like this. 14 is 2 times 7, and 6 is 2 times 3. So I have another 2 times 7, 2 times 3, and another 7, and a 1. I would call this 14 root 3, which I bet is probably this. Cool. If you add a decimal anywhere in it, If you add a decimal anywhere in your calculation, like even like right here, it'll give you the decimal version, Riley. Okay. All right. Doable? Cool. Like, I imagine you guys can do this. All right. Here's the other part. We have a super short chapter. Okay. Which means, so far, law of sines and cosines, okay or terrible? Okay, here's your choice. Do we want a chapter 6 quiz tomorrow? Or do we want to forego the quiz and just have a chapter 6 test next week? Scratch that, half year gone next week. We're going to skip the quiz. I might give you a take-home quiz over the weekend just to get a little padding for your grade. But I want us to be able to finish the chapter and have the test before you guys go. Cool. All right. NYO and Asog. Yeah. You're gone. You're gone. There's a bunch of you in here. All right. So we have 20 minutes. I want you guys to work on the following problems. Let me get over to Precalc. Okay, so apparently I did not even write a note that said do this problem the other day.
I don't work. Yeah, I don't work that much.
Law. So whatever, that's not the part that you need. Why didn't it do this? Okay, your homework. We're going to call this homework 6.2, which you will find waiting for you on page 427. Nope, 415, I'm sorry. Okay. I want you guys to do 13 through 17 odd. Oh, I love all these problems. 13 through 17 odd. I have a little bit more, but it's not terrible. (41) through 49 odd. Cool. All right, I'm going to pause the video, or end the video rather, and then